think you all covered totally different facets of testing in production, but they were all very complementary, and so it was just a really wonderful slate of talks to see next to each other. So just wanted to say thank you, and we just do one more round of applause for our speakers. So I think, to me, we talked a lot about the how of testing in production, and a question that's very interesting to me is the why behind that. And I think all the talks kind of talked about it a little bit, but that was something I wanted to dig into a little more. I think the kind of test in production mindset can change the way you think about writing and shipping code. And so I'm curious, when you think about the tools or approaches in your talk, can you think of cases where having that kind of visibility changed how you would approach writing or shipping software? Clay, I was hoping you could speak to this one first, because I think in your talk it's so clear that it might help you think differently about shipping code to production.
Yeah, I think there is kind of a change in thinking or a change in mindset. And I think definitely my focus on the CI pipelines born like directly out of like personal pain of managing that. I think in an ideal world, I think if you move to a more advanced deployment strategy, that visibility helps you react faster. That's the goal, and I know in talking with a lot of people, it seems like that's a direction as well. So ideally, it makes it safer.
That makes a lot of sense. Shipping faster, being able to react faster to changes in production. Priyanka, for Lightstep, do you see a similar sort of does it enable you to do the same things, or have you seen developers work with it and come away with some other change to their process that they didn't expect?
Sure, yeah. I think the biggest reason workflows are changing is with CI/CD, people are shipping constantly, and with microservices, there are these groups of developers who are operating very independently, and the amount of data that's generated is so high. And the fact is that you won't see everything in staging. There's just no way. So you have to get comfortable with testing in production and fixing on the fly. And we're definitely seeing that a lot with pretty much every company we talk to, whether it's the completely old school enterprise to a very new startup. So this is just a reality of working with external APIs, working in small groups of developer teams. And I think tracing, logging, metrics, all are being combined for teams to find their own solutions, to be ready to, as you said, react on the fly and be prepared.
That makes sense. Stephen, did the question remind you of any changes to your process that you've made?
Sure. I mean, for us, it's as they said. I mean, there's no way you're going to replicate kind of production level scale, production level performance issues in a staging environment. So in order to really, be able to get an understanding of what you've done works well, you've got to deploy it to production. One of the things that we've done, and a lot of other companies do, is the idea of feature flags, the ability to kind of like canary changes. So whenever we develop a feature, we have everything flag controlled in terms of this is new behavior. You have to take some explicit action to turn it on, and you turn on for like some percentage of your users. You have your monitoring set up so that you can see if that helps or not. And it is kind of like this gung-ho attitude of like, crap, we're just going to throw it out to the customers, see if it results in better things. If it doesn't, then you roll it back and you move on.
Cool. That makes good sense. That feeling of safety that comes from being able to just flip the flag is totally different than the way it used to be. I appreciate that. Priyanka, your talk made me think in particular a lot about instrumentation, and like you said, that's such a huge barrier for so many people to kind of get the visibility that they need to think more about testing in production. I'm curious to know, aside from the open tracing standard, if you see anything that vendors or open source contributors could do to try and make that easier for folks who are wanting to change their workflow to work more this way.
Sure. So I don't know if you guys have seen the XKCD comic where it's like there's 15 standards, there's everything wrong with these standards, and people discuss it, and the result is the 16th standard. So the suggestion that we are seeing work well is for people to agree on an instrumentation strategy through an open API spec ideally open tracing since it is already adopted so quite widely, and then putting efforts behind that, because lots of people are investing in open source, lots of people are trying to make everything compatible, and I think just unifying our efforts is what's the best case scenario. The good news is though that we're definitely seeing it happen. Every week I look in the community and there's a new open source project that's instrumented for open tracing, and most often I didn't even know until it's happened. So I think that wave and momentum needs to keep going, and it'll only help.
Clay, does anything come to mind, either as someone who did your own project or thinking of it from the vendor side?
Yeah, I think on my to-do list, but I ran out of time, is, I kind of hacked together this way of pseudo tracing a pipeline, and the next immediate thing I thought, I was like, oh, it'd be great to implement this in open tracing, so if it's out there, if people find value of instrumenting their pipeline, like, it'd be great to reuse. So I completely agree with what you said. I think the standards-based approach, XKCD speaks many truths around that, but it also feels like a really good direction at the same time. And I think it's something that a lot of people, myself included, are really excited about.
You should totally instrument with open tracing for that.
Stephen, what about you?
For myself, when I look at all these different things coming out in terms of monitoring, the different tracing, the different ways that people are communicating information, I mean, it really does reinforce the idea that your tools have to be pretty versatile, right? A few years ago, we had some customers that were still running like really old Red Hat Enterprise 10 releases or something like that, right? And they're running that alongside Docker, right? And so your tools need to be able to be versatile enough in order to pull in the information, do a good visualization, and just tie everything together. And I see like the tracing efforts as another, one of these other ways of getting really rich data into essentially the visualization of what's going on in your system.
That makes good sense to me. This is my last question for the panel, and then we'll open it up to audience questions. Stephen, I really love the idea of performance dark matter that you mentioned. That term really resonates.
Yes.
Like at Honeycomb,
Trademark John Hart.
Nice. At Honeycomb, we talk a lot about unknown unknowns, which I think kind of is a similar bucket. And I'm curious to hear from the three of you if there's a particular piece of dark matter that you found on your kind of test and production journey that has surprised you the most.
I mean, for us, it is, so when we're answering queries, when we're executing queries, we're often contacting hundreds of servers, right? And essentially latency gets smeared across all of them. And it really is difficult to understand kind of where all that latency is going. You have what we call GC bingo. We run in Java, right? A handful of those JVMs are going to be undergoing garbage collection. And when the JVM's going through garbage collection, it's not emitting any it's statistics. It's not telling you what's going on. It's only afterwards that you're going to uncover that information. And so it's really about just how you get information from these hundreds of things that are all interacting together and really kind of understanding how they all fit together.
I'm nodding my head about. I find myself agreeing with everything everybody says too, but no, I think there's something to that, and I'll just add that I think especially large organizations, one thing I've kind of observed is over time it seems like some teams are much better at it than other teams, are faster, and there's almost this something of a cultural aspect to it that everyone's in it together, building something for some hypothetical customer somewhere, but all too often there's that legacy component that the person that knew it well has moved on or been promoted, and they're bee dragons, which I didn't coin that, someone else said that for their talk, but it rings true to experience, and I don't know, I just feel like sometimes it's like an artifact of org structure or just like the way teams are organized as well.
I like that theory. I'm curious, do you feel like tools play into that very much, or do you feel like some teams with the same tools will do different things?
Yeah, I was at my first DevOps days last year, and there was like a quote poll. They asked the room, how many people use more than like 4, 5, 10 monitoring tools? When they got to 10 or more, I think about half the room raised their hand. So there's definitely something to that.
Priyanka, any dark matter you've seen with Lightstep that is stuck in your mind?
Yeah, so I don't know if this will qualify as dark matter just because it's so right there. But what we've seen with Lightstep and also with open tracing and user community is that once people have a system map and end-to-end visibility, there's so much low-hanging fruit that they can take care of. And that's why I'm saying I don't even know if it qualifies as dark matter. For example, like Twilio, when they started using the Lightstep system, they saw a reduction in mean time to resolution by 92%. That's not a small niche improvement, right? There's just like so, and this was within the first few months. And that just speaks to the fact that we've been flying blind. And a lot of, I just gave that one example to illustrate the point, but many people who you ask who are doing distributed tracing and combining it properly with like, you know, the trifecta of logging metrics tracing, there's just so much right in front of you that you'll be busy for a while enjoying the gains.
That definitely sounds familiar. All right, I'm going to open it up to audience questions. Does anyone have questions for any of the speakers?
I can start. So I would say that this is where service mesh technology is your very good friend. Are people here familiar with service meshes? Some nodding heads, some gonna go with like kind of. So basically, if you have a bunch of services and standardizing the creation of new ones as well as what is the sort of infrastructure layer on top of them with a service mesh can really help, because you have then the basic stuff that you need in the org without having to tell any developer anything that's not working on that infrastructure layer. So that would be my number one suggestion. And then after that, the education is more around, oh, look, you see this information on the top layer. Do you want to dig deeper? Go ahead and like instrument the code as you want to in your service. So that's a big suggestion I'd have.
Yeah, service meshes are super cool. And I think one thing that's come up in different conversations is get people familiar or comfortable with the idea by holding, you know, game days. PagerDuty called them Failure Fridays. Just kind of go through the scenarios, get even businessy people in the room. You know, it doesn't even have to be in production. It could be at you know, something under load test. But just kind of show them how quickly you can react to error. And while you're doing it, measure it. So like measure your time to recovery, show them a nice dashboard. People are reassured by that. But yeah, come hold it, like, you know, go through it in some, you know, test scenarios and then show them the data. That kind of tends to bring people around, I've seen.
Yeah, I'll agree with Clay. I mean, one of the biggest challenges is just kind of teaching people about the risk mitigation and putting risk in context. The founder of our company, Steve Newman, he's in a previous life, he worked at Intuit after an acquisition. And he always tells the story about them finding a bug the day after they burned all the CDs with the release of the software, right? And there's, I mean, undoing that is horrendous, right? But today we live in a world where we're pushing software every minute to our servers. So if there are problems, you know, we can fix them very quickly. So it's all about having a good infrastructure for, you know, knowing when things are going wrong, mitigating when things are wrong, and just kind of socializing that. You know, I worked at Google for 8 years. You know, you would think that, I mean, of course, they take their users very seriously, as they should. But yeah, we experimented with the users all the time. You know, you push out a 1% experiment, especially on the ad space, right? I mean, the ads for Google makes them billions of dollars per day, sort of. And they're willing to risk, you know, losing money in order to just see if something was more effective. And it was all about just measuring things, having, you know, the data back up the fact that this is a good thing to test, and often it leads to good things. I mean, it's true that you're not going to understand from the get-go every little piece that you have to monitor, right? But still, from your understanding your infrastructure, you're going to know the major kind of breakpoints that you should be checking, right? You're going to monitor, you know, when a request has started processing, when it ends. You're going to monitor various checkpoints from it throughout that process. So at the very least, that you're going to get some idea when things start going wrong. You're going to know, okay, it's this stage in the request processing. You know, one of the things that we do also is, you know, ask ourselves, why don't we have the information? A lot of times we don't have the information because we want to expend the effort of writing to the log, the bytes it's going to consume and so on. So you build in the idea of having different verbosity levels in terms of your logging. This is something that we use all the time in terms of in certain circumstances, turning on more logging in order to get more detail. Again, you do have to be a little proactive to think about that. But if you take it kind of like from an organized point of view, it's not too hard to do. We talked about distributed tracing. I mean, Dapper at Google was one of these projects that kind of exposed that. You would, on a per request basis, put a lot of information. It was not predetermined ahead of time all that information would be written to the disk. It was just based on a coin flip. So you had the ability to kind of like turn up and down how much information was being written to your logs and therefore to your monitoring in order to extract information out afterwards. So you have to go in with some versatility in mind.
I couldn't agree more. There was a really interesting paper recently by David Woods. He's a professor at Ohio State that studies cognitive systems, and he made the point that the worst outages are always surprises. You're always going to be surprised because it challenges the way you think your system, your complex, ever-changing system works. Didn't match how it was actually working, and that maybe combined across team boundaries can create a really disastrous outcome. And I think to your point about maybe modifying log verbosity or looking at distributed traces, it's all getting to this idea of we've got to be able to become better experts at these systems, and especially be able to investigate things in different ways and different angles beyond a pre-baked dashboard when something bad happens. So yeah, I guess I didn't really answer your question, but I think there is something to this idea of we need better tools, but we also need to just consistently recognize that it's always going to be a challenge to build expertise in these very complicated things we're building.
Along the lines of what Steven said, and also Clay, it's true that it's impossible to always have the right metrics set up, always have the right SLOs, etc. But like he mentioned with the log aggregation, if you increase it for some time, then suddenly you have all this information. Similarly with tracing data, if you have a recall that's, let's say for the next 10 minutes, you can see your entire system in complete omniscience, then even though you did not have a predetermined set of metrics set up, you can at least deep dive into the problem the minute it happens and fix it. So it's not as good as having predicting it and not letting it occur, but at least the minute it happens, you have all the information to go solve the problem.
No, I absolutely think there's two sort of undiscovered countries. One is the language runtimes, because they're all developed independently, and so when you come in and you're like, now we want to glue it all together, it's like, oh, let's discover every bad decision everyone ever made in the history of computer science and then try to glue all of that together, and it's really difficult. So it'd be a lot better if we could figure out what information in general are we trying to aggregate out of these systems, and could we all agree to some baseline and get that into the language runtimes. I'm sure in the meantime, yeah, it's just language dependent stacks, and then whatever is the sort of lowest common denominator of things you can get out of all of those, we're going to try to grab that. I could see that coming next, for sure. Yeah.
Hope that was all right. We had an expert, so.
If I could say one thing, I think this is a great question. I mean, after we talked about the performance dark matter, I realized, I want to talk about this idea. When you are doing these distributed tracing, you do come down to a fundamental question of, this request, was it slow because the sender had difficulty sending it, or was because the receiver had difficulty, accepting it? And you do get into this idea of, okay, was the JVM just paused, and that's why it looks like the request took a while to arrive? In my experience, I mean, it really just comes down to correlations, right? You have to narrow it down to, okay, either it's a network issue at the sender level, or it's a receive issue. Looking at things in aggregate, looking to see if, overall the correlations, if it looks like this particular receiver wasn't a GC pause, that's going to give you more information. Or looking at in terms of network channels, are there just a prevalent number of issues with these messages being received across the whole network, then it'll be a network issue. So it's just more data helps, I think.
All right, I think we have to leave it there. Just wanted to thank all of our speakers one last time.